Scotty, you're welcome. You're welcome, Scotty. Okay, you're welcome to our online lectures for today. Welcome to online tutorials with From Eternity the Schoolboy. Today we'll take a look at physics. Today we'll take a look at physics, and our topic is equations of uniformly accelerated motion, part 2. We started this topic in our last physics class. Black, you're welcome. In our last physics class. So today we move over to the second class, second contact on this topic, and we solve questions on this topic in today's class. Please like this lecture, share the link to your contact, invite them to join. They have a lot to learn from today's class. Okay, so let's pick a question. I have a question here, but before that, I want to, in our last class, we proved the four equations of, four of them, equations of uniformly accelerated motion. So I'll list them for reference purposes before going into the equation I want to solve. So we have the one that says that V is equal to U plus AT. We have the one that says that, are they 4 or 3? Okay, let's continue. We have the one that says that S is equal to UT plus half AT squared. Then we have the one that says that V squared is equal to U squared plus 2AS. These are the 3, not 4, equations of what? Uniformly accelerated what? Motions. So I have a question here. I'll write a question on the board, then we'll take it up from there. Okay, this question is from NECO 2001 Physics. NECO 2001 Physics, okay? That's where the question came from. NECO 2001 Physics. Okay. The question says, Queen, you're welcome. Abdullahi, you're welcome. The question says, a body whose initial velocity is u, comma, that should come out here, comma, is uniformly accelerated to a final velocity v in t seconds, full stop. If the distance traveled is acceleration is a, which equation is incorrect for the motion of the body? A says S is equal to ut plus half at squared. B says v square is equal to u squared plus 2as. C says v is equal to u plus at. D says v is equal to u plus 2as. While E says S is equal to half v plus 2 in bracket times t. As I said before now, this question is from NECO 2001 Physics. So let's look at the question. I listed three. These are the three standard, three equations of motion we know. But let's look at the option. Option A says S is equal to ut plus half at squared. Is correct. Look at it here. So I will choose, this one is correct. The question says we should choose one that is incorrect. B says v squared is equal to u squared plus 2as is correct. Then C says v is equal to u plus at. Look at it here, is correct. But look at D. D is an aberration of this B. They just remove the squared here and give you something else. So it's wrong. D is not correct. So I will choose D as the answer. But let's look at E. Even that's why it's not good to cram equations of motion. Don't cram formulas in physics. Try to understand where each formula was derived from. Every formula in physics came from somewhere. So try to find any formula you see, don't just memorize it. Try as much as possible to trace where the formula came from. So if you watch the part 1 of this class, that should be last week. If you watch the part 1, it's in our YouTube channel. I proved all these things there. Please go there and watch this part 1 of this. Equations of uniformly accelerated motion. I took time to prove all these things. I wouldn't go back to it again since we already have it uploaded. So just go and watch it. You realize that this equation you see here played a vital role. In this equation. Even this equation. In fact, it started from this down to this. Now, let me explain this. Distance covered is average velocity. This is average velocity times time. Actually, average velocity is simply what? Total distance covered over time. That is average velocity. Average velocity is equal to what? Total distance covered over what? Time. This is average velocity. But what is average? It means that you check the average of the initial velocity, get the initial velocity, get the final velocity, and get the average. That means you add the initial velocity to the final velocity and divide by 2. You get average velocity. So this is simply v This thing is, let me, excuse me. I hope I've not, I'm okay. I'm still within the frame. Okay. Let me come closer, a bit closer. So V is equal to S over what? T. This V bar, this is average velocity is equal to distance, total distance over time. This B bar is simply V final velocity plus initial velocity over what? 2. So this is equal to what? S over T. So that means total distance is equal to what? V plus U over 2 times what? T. If you bring out this thing now, it becomes what? V is equal to 1 over 2. S is equal to 1 over 2 V plus U over what? Times what? T. Look at it here. So I also pick this as correct. This is also equation of this motion. But it's not the answer. The answer is what? D. So E, C, B, A. They are all correct. So the answer to NACO 2001 physics, sorry, the particular question is not here because I just got this online. The answer is actually what? D. The answer is actually what? D. All right. Please, if you have any question, feel free to ask. If you have any question, Mirabella, you're welcome. You're welcome. If you have any question, please feel free to ask. Jenny P, you're welcome. Please feel free to ask your question if you have any. Okay, let me look for another question before our time elapses. Let me look for another question. Let me look for another question. Vianney, you're welcome. I'm still looking for questions to solve so we can. Okay, here is another question. Here is another question. Okay, the question says, okay, let me write on the board. Okay, so let's look at this. This question is from 1985 JAMB Physics. 1985 JAMB Physics. So let's look at this question. The question says, a car starts from rest and moves with a uniform acceleration of 10 meters per second for 10 seconds. The distance it covers in the last 1 second of its motion is A, 95 meters, B, 100 meters, C, 500 meters, D, 905 meters, E, 1000 meters. Okay, so let's look at the question critically. So the car started from rest. Before you can know the right equation of motion to use, look at the parameters you are given in the question. If you look at the parameter in the question says that the car starts from rest. So initial velocity is 0. And the big give us anything about second final velocity. So what you see here, it moves with a uniform acceleration of what? 10 meters per second for 10 seconds. Then they wanted to find the distance it covers in the last 1 second of its motion. The distance is covered in the last 1 second of its motion. It moves with an uniform acceleration of 10 meters per second for 10 seconds. So that means it came to rest after the 10 seconds elapsed. That's the meaning. So how do we now, if you watch now, the only equation of motion that has distance and acceleration and in time and initial velocity is this equation. Let me write down the equation so that you understand what I'm talking about. V is equal to U plus AT. S is equal to UT plus half AT squared. V squared is equal to U squared plus 2AS. These two, they have final velocities and they don't have time. Okay, this one has time. This one has initial velocity. It has final velocity, but there's no distance. This one has distance, has initial velocity, has time, has acceleration. This one has final velocity, has initial velocity, has acceleration, has distance, but no time. So out of these three equations, the one that we use to solve this question is this one. The one that has distance. Distance is here. Starting from the beginning of the question, 0. If a car starts from rest, that means the initial velocity is 0. So it has initial velocity, which is what? 0. Then it has distance. Distance is there. Distance is what we are asked to do was calculate. Good. Time, there's time there. Then there's what? Acceleration. There's what? Acceleration. So the question now says that if you find the distance it covers in the last 1 second of the motion. The last 1 second of the motion. So what does this tell us? What does this tell us? It says something. Watch. With a uniform acceleration of 10 meters per second for 10 seconds. But we were asked to find the distance, it already covered distance in the last 1 second. In the last what? 1 second. So what's the answer? So it's simple. This thing they say here indicates what? It indicates what? Difference. It indicates what? Difference. It indicates what? Difference. It indicates what? Difference. Watch. Here we have 10 seconds here. And here we have what? 1 second. In the last 1 second, if you use the 1 second and subtract, if you use 10 seconds and get subtract from the 9 seconds, it will give you the same answer. But just know that it depicts what? A difference. And what is that difference? If you now say, if you put 1 here, it becomes 1 square times 10, which is 10, divided by 2, give you what? 5. Then if you come here and put 9, don't worry, let me solve this. So here now we have solution. First of all, you start from for 10 seconds. For 10 seconds, remember that S is equal to what? UT plus what? Half what? AT squared. U is already 0, so S is equal to what? S is equal to what? 0 times what? Now, the distance for the 10 seconds is what? This time should give you what? 10 plus half. Acceleration is what? 10 times what? 10 what? Squared. Here will give you what? 0 plus 10 squared is 100. 100 times 10 is 1000. 1000 divided by 5 is 2 is what? 500. So this gives us what? 500 what? Meters. 500 what? Meters. Now, it accelerated for 10 seconds for even acceleration in 10 meters per second for 10 seconds. Then we are calculating distance it covers in the last 1 second. In the last 1 second. So This 10 here minus this 1 second give us what? 9 seconds. Already covered. So if you use distance at 9 seconds, we have what? 0 times what? 9 plus half times what? 9. So here is 10 acceleration times what? 9 what? Squared. 9 squared is 81. 81 times 10 is 810. 810 divided by 2. 810 divided by 2. Here alone is already 0 because 0 times 9 is 0 plus 810 divided by 2 is 405. Here is what? 405 what? Meter. So the answer is what? 405 what? Meter. Now, if you want to know, calculate the distance it covers in the last 1 second. You subtract this distance in 10 seconds minus this distance in what? 9 seconds. So if you subtract it, you have, that is, here is distance S10, here is S what? 9. So S10 minus S9 is equal to what? 500 what? Meter minus what? 405 what? Meter, which gives us what? 95 what? Meters. So the distance it covers in the last 1 second is what? 95 seconds. Sorry, 95 meters. 95 meters. What's time? Okay, we'll see how 18 minutes to go. 95 what? Meters. So the answer here is what? A, 95 meters. Let's go over it again. It says that the car starts from rest and moves, so initial velocity is 0 with a uniform acceleration of 10 meters per second for what? 10 seconds. If you are told to just calculate for 10 seconds, the answer would have been what? 500 meters. Good. Then if you are told to calculate for just 9 seconds, the answer would have been what? 405 meters. But we are asked to calculate in what? In last 1 second. So to get it, we'll subtract that for 10 seconds. We'll subtract that for 9 seconds. From that for what? 10 seconds. Then you get that for what? 1 second. So if you mistakenly use 1 meter, 1 second and put in the equation, you just end up getting 1 squared time, which is 1 times 10, which is 1, which is 10 divided by 2, 5 meters, which is wrong. So the best thing to do was subtract, calculate that of what? 10 seconds, calculate that for what? 9 seconds, which is already covered 1. Because they said they didn't tell you after, they didn't tell you in 9 seconds, they said in the last 1 second. So calculate the one covered for that 9 seconds already. Then subtract it from the one it would have covered if it was completely 10 seconds. So if you calculate the one of 10 seconds complete, then you calculate the one of 9 seconds complete. If you subtract it, what will remain is the one in the last 1 seconds. So that's why the answer is what? 95 meters. 95 meters. So this is the answer to this question. Just we'll be able to see another question. Please, if you have any question, feel free to ask. Let me shift so you can look at the board. If you have any question, feel free to ask. Thank you, Scotty, for liking the live. Thank you. Please share with your friends. Share with your friends so they can follow up and join us on these classes. Thank you very much, Scotty. All right. So please, someone should comment. I don't know how is the audio. Is the audio clear? Please, someone should comment. Please, someone should comment if the audio is clear. And also the visual. Please, someone should comment, please. Someone should comment. All right, while we wait for the comment, let's continue. So this is actually how to calculate, solve questions like this. Okay. All right. So let's see if we can have another question before our time elapses. Okay, this is our last question for the day. Let me clean the board. I've seen our last question for the day. Okay, let me write the question. Okay, so let's look at this question. This is our last question for the day. The question says, a body starting from rest travels for 100 seconds with a uniform acceleration of 1.5 meter per second square. That is meter per second square. Correct it. What distance does it cover in the last 2 seconds? Option A, 270 meters, B, 262 meters, C, 297 meters, D, 308 meters. This question is the same, is similar to the last question we solved. So let's solve it and see what our answer will be. Let's solve it and see what our answer will be. Okay, let's go. Solution. As usual, if you look at the question, you will realize that it has initial velocity, which is 0. It has time. It has acceleration. This is meter per second squared. Then it has the distance we are asked to look for. So this is the equation that will fit in. S is equal to ut plus what? Half at squared. So we have, first of all, we calculate S at 100 meters per second, 100 seconds time. Then calculate S. Remember, the question say in the last 2 seconds. So 98 seconds would have passed. It was supposed to be 100 seconds, but we want to calculate it in last 2 seconds. So 98 seconds would have passed. So we calculate in 100 seconds, complete. Then calculate in 98 seconds. Then after we subtract that of 98 seconds from that of what? 100 seconds and get our what? Answer. So let's do it. So in 100 seconds, S100, we have what? Remember that the initial velocity is 0. So here is 0 times. The time here is what? 100 seconds. Times 0 times 100 seconds. Let me just leave it. Plus half times. Acceleration is what? 1.5. Times time is 100 seconds. 100 seconds squared. Of course, here is 0. Here is automatically what? 0. So here is 0 plus 1 over 2 times 1.5 times 100 times 100 is 10,000. So we have 10,000. So 10,000 times 1.5 is 15,000. 15,000 times divided by 2 is 7,005. So here is what? 7,500 meters. So let's calculate for before getting to the second, the last 2 seconds. It would have covered for the 98 seconds. So S98 is equal to 0 times what? 98 plus half plus times 1.5 times 98 what? Squared. Here is automatically what? 0 plus half times 1.5. 98 times 98 is what? Let me do sharper, no time to wait. 98, this is 64, 4, 6, 8 times 9. 64. 8 times 9 is 64 plus 9 is 8 times 8 is 64. Plus another 8 is 72. Yes, because 4 times 9 is 36. 72 plus 6, 78. 9 times 8 is the same 72. So you put 2, 7, put here. 9 times 9 is 81. 81 plus 7 is 88. So you have 88. So here is 4, 0, 1. 7 plus 1 is 8. Plus 8 is 16. 1. So we have 9,604. So we have 9,604. If you divide this by 2, we have, if you divide this by 2, we have 2 0, we have 4. 96 divided by 2 is 8, is 48. So we have 4, 0, 96. So 4,802 times 1.5, certain are saying 15 over 10. So if you multiply this by 15, you have 4802 times 15. Since this is taking our time, but let's just do it. It worth it. Everything is not calculator. But this is supposed to be jump question. Why is it? Okay, it's not jump question. No. There's no. I don't know the question, so they really indicate. Okay, let's go. This times 15 is what? 5 times is just this. Okay, 5 times 2 is 10. 5 times 0 is 0 plus 1. 5 times 8 is 40. 5 times 4 is 20 plus 4, 24. Hope I'm right. 0, 1, 0, 0, 1, 0, 1, 4, 40, 24. I'm correct. This is here is now 2, 0, 8, 4. I hope I'm correct. 2, 0, 8, 4. I'm correct. 0, 3, 0, 12. 1 here. 7. 72,030. So this is roughly 7,203. 7,200. So this OTP is 7,203 meters. So this distance is 7,203 meters. So if you want to calculate distance in 98, if you get to calculate distance covered in the last 2 seconds, you subtract. If you want to calculate distance traveled in the last 2 seconds, you subtract distance in 100 seconds minus distance in 98 seconds, which is equal to what? 7,500 meters minus, which is 7,500 meters minus 7,203 meters. This will give us what? 7 will go. 500 minus 203. Here is 7 meter. Here is 7 already. For this 7 to occur, that 1 lost here. So 9 should be here. 9. Of course, you've taken 1 from here. Remaining 4. 4 minus 2 is 297. So the distance covered in the last 2 seconds is 297 meters. So let's see whether the option is there. It's option C, 297 meters. 297 what? Meters. So the answer is what? 297 meters. 297 meters. 297 meters. The answer is 297 meters. Okay. So we've come to the end of our today's class. It's roughly 1 minute to 11. Thank you very much for being with us, and God will bless you as you do so. Before the end of tomorrow, we will upload all the lectures we had today, starting from our actions and uses of medicines, AM 321, down to our pharmaceutical calculations, BDT 253, and this physics. So I'm going to upload all of them on our YouTube channel. Please go there to watch the full lectures, the pre-recorded lectures, and other lectures. How to access lectures is very simple. Subscribe to our YouTube channel. The channel name is Farmeternity the Schoolboy. The same name with this TikTok you are watching now. Follow us on TikTok, then go to YouTube channel Farmeternity the Schoolboy. Click the subscription button and subscribe. Then there's a bell-like button, a button that looks like bell by the side. Click on it so that whenever we upload any video, you'll be one of the first followers or subscribers to watch the videos. So that's what you do. Then go to playlists. This lecture, all lectures there are categorized subject by subject. Once you click the playlist, you select the subject you are interested in and watch it. So all lectures we had from 8 p.m. this night to 11 p.m. we uploaded under the 3 different headings. First one is pharmacology, because AM is not pharmacology. AM is just the pharmacology for pharmacy technicians. That's why when I was teaching that, I was trying to follow the curriculum, not to go deep. Then you also talk of what is it called? Go to, you see column for pharmaceutical calculations, then go for that of physics. Please subscribe, share, invite others, encourage your friends to be with us, to join us in this class. And God will bless you as you do so. See you next time. I'm still your best friend from eternity, the schoolboy. God bless you.